presentation today from Energy Expert. Okay, so today we are going to be talking about the last component of our solar systems. We talked about solar panels, we talked about the inverter, we talked about the charge controller. So today we are going to be talking about the storage. And for our purposes, it's going to be mainly the battery. And for our purposes, again, we're not going to be talking about primary batteries, which are not rechargeable. We are mostly interested in secondary batteries, which are rechargeable. So, why do we need storage? Right. We know that we are going to have light during the day, right? So during the day, there is no problem. We are going to have energy harvesting from energy harvest from the sun. But what do we do at night? So at night, we need somewhere where we would have stored that energy so that we can use it during the night. That is the function of the battery. And the batteries come in different sizes. And the rating of the batteries is usually in ampere hours. This figure tells us how much current in amps can a battery give out in 1 hour. For example, we've got 100 Ah batteries, we've got 200 Ah batteries at nominal voltage 12 volts. Right, what it means is for a 100 Ah battery, what we are mainly saying is this battery will give 1 amp for 100 hours, or 2 amps for 50 hours, or 100 amps for 1 hour. However, this is just to determine or to give it the size, but usually there is an additional specification which is called the C rate. The C rate is the safe discharge or charge rate that our battery is designed for, and this rate, if exceeded, then we are bound to damage our battery. So it is crucial to note the C rate of the battery so that you don't exceed it during charging, and then you don't exceed it during discharging. In other words, when you are connecting a load, you have to make sure that the DC equivalent power that is coming from the batteries will not be such that you exceed the discharge current, which is greater than the C rating of the battery. So we have got mainly 2 types of the batteries. We've got the lead acid battery, and then we've got the lithium ion battery. Right. The lithium ion is the new technology, and it has got so many advantages over the lead acid battery. However, it also comes at a cost. Those advantages, they come at a cost. What are the advantages? The advantages of lithium ion battery is it lasts long. It has got big specific energy density. It has got big specific power density and energy density. In other words, if we are to consider space as something that we are not having, or that we are not given enough space, then lithium ion will be ideal because we get so much energy from a small battery, or from a small volume of storage. So the lead acid, on the other hand, it also has its own advantages. It is cheaper, and it is found in 12 volts, whereas the lithium ion is these days there's lithium iron phosphate that can be used to make 12 volt batteries. Otherwise, it was not possible to have a 12 volt battery which is lithium ion. But nowadays, with the application of lithium phosphate, it is now possible. So the lead acid is found in three types, mainly differentiated by the state of the electrolyte. So it can be gel, it can be flooded, it can be absorbed glassmate. So all these, they are lead acid, but with the difference in the form of the electrolyte that is being used. So for flooded, mainly found in cars and in some deep cycle batteries, actually not some but many, it's still being used. But this battery, when you use it, you have to understand that you can't use it upside down. It will always have to be upright because of the nature of the electrolyte. It can spill over and so forth. But the other two types, the gel type and the glass, the AGM, the absorbed glassmate, you can use it in either way because the electrolyte is like in solid form, so it will not spill over. These batteries or these types of lead acid batteries are applicable in different forms. The gel and the flooded can operate best at higher temperatures, whereas at low temperatures it might not be ideal for them. So if you have to choose and you are from very low temperatures, then you have to go for the AGM type or vice versa. So those are the few things that we have to note when we are procuring these batteries. Then one advantage again of lithium ion versus the lead acid is about the depth of discharge. Right. Depth of discharge is simply telling us the amount of energy that you can take from the battery. For lithium ion, you can go to as much as 80% depth of discharge, 90% depth of discharge is not a problem. It doesn't suffer from memory loss. In other words, you can charge and recharge from whatever depth that you would have taken power from. Whereas the gel or the lead acid, gel, flooded or AGM, the recommended depth of discharge is 50%. The moment you go beyond 50%, you are bound to make it lose life at a faster rate, and also it will lose capacity at a faster rate. In other words, what we are saying to lose capacity is it will start, if it was 100 Ah, it will start to deteriorate faster to possibly 90 Ah, 80 Ah, and that rate of deterioration is the one that we are saying it will be faster. So it is always advisable to make sure that the lead acid batteries are not discharged to more than 50%. So how do you go around this problem? If your energy demand is such that you need 100 Ah per day, then you have to buy 200 Ah of the battery, so that every day you discharge 100 and you remain with 100. In other words, the two batteries will contribute 50% each. This one will give you 50 Ah, this one 50 Ah, and then your energy requirements is fulfilled, whilst at the same time not exceeding 50% depth of discharge. 50% depth of discharge is more like saying you are remaining with the state of charge of 50%. And one other specification that is important to note is the number of cycles that your battery will have. The number of cycles relates to the life or the expected life. Mainly the gel and AGM and flooded are within the range of 1,000 to 2,000 cycles, whereas the lithium ion is 3,000 to 5,000 cycles. In other words, a cycle is a charge and a recharge. If you charge and discharge, that's one cycle. So, loosely speaking, we are saying a day can constitute a cycle. So if you want to find out how much your battery is going to last, it's then number of cycles divided by 365, then you get the number of years that the battery will last, giving almost efficiency that is within 90%. So I think for the batteries, that is what we can talk about today. Then we will discuss more about the sizing and so forth in the next videos, where we will now start to do practical applications, practical problems that we face with these systems, and how we go about solving such problems. Otherwise, please subscribe to our channel, like and share so that we grow our channel. Interesting things are to come. Thank you.
Book a free consultation today from Energy Expert.